All right, calculus, this is for Thursday, September 17th. So if you're at home, if you're a red team, you're doing this at home. It's pretty easy, so hopefully it's no big deal. All right, so we have three things to talk about today. We have slope, we have horizontal lines, and we have vertical lines. So if I look at this line here, the blue line, I'm sorry you can't see all the other things. What is the slope of that line? When we have horizontal lines, what is the slope of any of those lines? And you're right, the slope is 0 because it doesn't go up or down. Now, how do I find the equation of this line? Now, let's assume this is as big as I can make it. Okay, it looks like it's sitting on -1, doesn't it? Looks like it's sitting at -1. So because it goes through the x-axis, we will call this y. Oh, what did I say? X-axis. Holy cow. Because it goes through the y-axis, we're going to call this y equals whatever number it is, -1. Because notice every point on that line is the y value is -1. So like this one would have been -2, -1, -3, -1. This one over here is 3, -1. All of the y's are -1. So we say y equals -1. Okay, this one, man, these pictures are bad. They were a lot better when I put them on the whatever. Okay, anyway, so again, this goes for this one. What is the slope of this line? The slope of this line is the same. The slope is 0 because it's horizontal. And it looks like maybe -4, -2, -4, -6, -8, -10. So I think this is y equals -4. Goes through the y-axis. Don't think about which one it's parallel to. Think about which one it goes through. It goes through the y-axis. Okay, and then this slope, you can make up whatever number you want to. I think it's supposed to be 7. Y equals 7. That line right there is the equation. Oops, I put that in the wrong spot. So y equals 7 is the equation, and of course the slope is 0. So every horizontal line has a slope of 0, and every horizontal line looks like y equals some number. We sometimes use b because it's the y-intercept, but you don't have to. It's just some number. It goes through the y-axis. That's why we call it y equals. Okay, vertical lines, the slope of this, any vertical line, remember the slope is undefined. There is no slope. But we usually like to say undefined instead of no, because some people get confused with no and 0. So it's an undefined slope. It's going through the x-axis. So what are we going to call that? 2, 4, 6. So this is x equals 6. I don't know, whatever that number is, which we can't read. Okay, the slope of this line here looks like 2, 4, 6, 8. So it looks like it's supposed to be x equals 7, perhaps. And it's an undefined slope. All vertical lines are undefined. I'm sorry, I'm getting ahead of myself and not doing them in the right spot. Slope of this line, of course, is still undefined. Always undefined, vertical. And this one doesn't even have any numbers on it. I think this is supposed to be a 5. And this is supposed to be 0. And so I think it's 2. So this is going to be x equals 2. It goes through the x-axis, and it's always undefined. Okay, so those are horizontal and vertical. Make sure you can recognize those. Now these slopes, you should be able to tell me if it's positive slope, negative slope, 0 slope, or undefined. Okay, so we are living in the United States, so we'd read left to right. So notice I'm going uphill. So this is usually talked about as being a positive slope. This one, because I'm going downhill, this is negative. And whenever you do calculations, just double check that your positive and negative is right. Horizontal lines, those slopes are always 0. And vertical slopes, those are always undefined. Okay, all right. So remember, always double check, make sure that it makes sense. All right, so here's my slope equation. I know you remember this one, y2 minus y1 over x2 minus x1. Sometimes we call it delta y over delta x. So when you're doing 2 points, it doesn't matter which one is 1 and 2. It matters which one you start with. So x1, y1, x2, y2. So my formula is y2 minus y1 over x2 minus x1. So y2 is negative 3 minus y1 is 5 over x2 is 3 minus a negative 7. So that means this is negative 8 over, and 3 minus negative 7 is 10. So simplifying that, it's negative 4/5. So we leave it as fractions. We never make slopes decimals. All right, this slope, y2 minus y1 over x2 minus x1. So this is x1, y1. This is x2, y2. So this is negative 2 minus 1 over negative 6 minus 0. This is negative 3 over negative 6, which is just 1/2. So this is a positive slope. The other one was a negative slope. So this one would go up 1 and to the right 2, up 1 to the right 2, and it would have a slope like this. This one would go down 4 and to the right 5. So it would have a slope like this, sort of, that kind of thing. So a negative slope and a positive slope. Okay, the other thing we have to talk about is rates of change, right? When we talk about slope, that's often the rate of change, because oftentimes it's time, something versus time. So at 1 o'clock, or at time 0, at 1 o'clock, the water level is 13 inches. So if I have a pool, I like to draw pictures. I don't usually get to draw pictures. So at 1 o'clock, the water level is 13 inches. So this water level is 13. And by the time it's 2:30, the water level has changed to 28 inches. Do you see those as points? Okay. So we can think of it as the first one at 1 o'clock, it's 13 inches. So if you want to say 1 comma 13, you can. That's fine. At 2:30, the water level is 28. Well, we can't really say 2:30, but we could say 2:30 seconds is a half, right? So at 2.5 hours later, it's 28 inches. So I could do that. Or I could just say in my head that it went from 28 to 13 in 1.5 hours, right? So what's my rate of change? 28 minus 13 is 15. 15 divided by 1.5 is, I just want to make sure I have the right answer. 15 divided by 1.5, I'm pretty sure that's 10. So what does that mean? If it's 10 over 1, so that means it's 10 inches for every hour, because that's how we did it. We did it per hour, because 1 o'clock to 2:30 is 1.5 hours. So 10 inches in 1 hour. I don't know if that's fast or slow in a pool. I don't have a pool. So 10 inches in an hour, that's my rate of change. Okay, so this one, 1938. In 1938, my wage was 25 cents. And by 2009, my minimum was $7.25. You see them as points? So we're looking for the rate of change. So that's per year. So year needs to go on the bottom, which is good because this is year and this is money, right? Okay, so it makes sense, money per year. So the year has to be on the bottom. So the top is going to be 725 minus 25 over 2009 minus 1938. So the top is easy, 7. So 2009 minus 1938 is 71 years. So 7 divided by 71 is like 10 cents. It's 0.0985915, blah, blah, blah. So I'm going to round that to 10 cents. So this is approximately 10 cents, 0.10 per year. So this is 10 cents per year is my change in minimum wage, which if you think of that way is rather pathetic. Anyway, I think that's all there is. So good luck.